Chapter 7-3, Proving Triangles Similar. Okay, so if two triangles are similar, their angles are congruent. This is going from one triangle to the other triangle, okay? And the sides are proportional to each other. So that would be the definition of similar. So just to give you a quick image here, these two triangles right here are similar, okay? And I'll explain why later. But as you can see, one triangle is just a bigger or smaller version of the other triangle. So that's what it means when the triangles are similar. And I'll just mention real quick, if we know that two angles are congruent, from two pairs of angles are congruent from one triangle to another, then we know that their third angles are also going to be congruent, okay? And that's because the interior angles of the triangle always add to 180 degrees, all right? So because the 60 and the 50 angles match, then angle F is going to be congruent to angle C. Okay, Postulate 7-1, angle, or AA similarity. Okay, this is the most common one, and especially most common on the SAT. Okay, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, so if you can match two pairs of angles congruent, then we know the triangles are similar. So here we have S and M are congruent, and also R and L are congruent. So triangle SRT is similar to triangle MLP. All right. Notice they matched the corresponding angles. See that S is congruent to M, so they put the letter S first, and they put the letter M first. All right, and then you have angle R congruent to angle L. They put R second and L second. All right, so when you make the statement, you want to match the letters on both sides of the statement. Okay, and this squiggly line right here means similar to. Okay, problem 1. Are the two triangles similar? How do you know? Let's check out the diagram. Okay, now recall from geometry. All right, let me highlight this here. Recall from geometry, when you have this X shape with two straight lines, those are called vertical angles. All right, so when you see the X shape, those are vertical angles, and vertical angles are congruent, the ones across from each other. All right, so I am going to mark this angle here congruent to this angle here. All right, and now the other angles that match are this 45-degree angle and this 45-degree angle. All right, so now we can make the similarity statement. All right, and we have to trace both triangles the same way. So I'm going to start at the 45, then I'm going to go to the vertical, and then I'm going to go to the angle that's not marked. Okay, so I'm going to say RSW. And the squiggly line means similar to, and then trace the other triangle the same way. 45 to the vertical to the one that's unmarked. So that's going to be VSB. All right. So triangle RSW is similar to triangle VSB by AA. Okay, that's angle, because we found two pairs of angles that match, that are congruent. Okay, part B. Again, they want us to state if the two triangles are similar, and how do you know? So part B is JKL and PQR. Let's check it out. Okay, here's JKL and PQR. All right, so looks like we have to find the third angle. So if this one is 30 and this one is 70, this one right here is just going to be 180 minus 30 minus 70, right? The whole thing, interior angles, the whole thing adds to 180. So I just subtract this one and this one, okay? And that's going to be 80 degrees. All right? And we can see there's no way it's going to match, okay? The 70s match. The 70 matches the 70, okay? But this one is 80 and this one is 85. So there's no way this one is going to match this one here. If you want to calculate it, you just subtract these two from 180. It's going to be 25, okay? So as you can see, we do not have two pairs of congruent angles, so these are not similar. Okay, please pause and try Got It problem 1A. Are the two triangles similar, and how do you know? Okay, so we have the 90-degree angles match. All right, we have to find the third angle on one of them. All right, so this one here, that angle is going to be 180 minus 90 minus 51. Okay, and that's going to be 39. So as you can see, 90 matches 90 and 39 matches 39. Okay, they did not give us the vertices. They didn't give us letters for the vertices or the points. So we can't really make the statement, but we can say they are similar by AA. That's angle, angle. Okay, please pause and try Got It problem 1B. Again, see if you can determine if the triangles are similar. All right, so recall from geometry, when you have two sides that are congruent, you go across from those sides and you mark the angles congruent. So if this one is 68, this one is going to be 68. All right, and it looks like we need our third angle here. So this one here, that's just going to be 180 minus these two. Okay, so it's minus 68 and minus 68. All right, so 68 and 68, that's 136. 180 minus 136 is going to be 44. Okay. So it looks like there's no way it's going to match. Okay, because this one here is 62, and there is no angle that is 62 in this triangle. Okay, you can do the same thing on this one and find the three angles, but it's unnecessary. Okay, so the answer is no. All right, once you have all three angles and it doesn't match one of the other angles, there's no way they can be similar. Because we said in the beginning, similar triangles, all three pairs of angles are congruent from one triangle to the other. Okay, next up, Theorem 7.1. That's side angle side, or SAS, similarity theorem. All right, if an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the angles are similar. Okay? What they mean by the sides that include the two angles, that means that the angle, okay, the angle is in between the two congruent sides. All right, so that's why the theorem is called SAS. The A is in the middle. The angle is in between the two sides that are congruent. I'm sorry, small correction. The angle is in between the two proportional sides. Okay, the sides don't have to be congruent for similar triangles. They have to be proportional. All right, so let's take a look at the example here. All right, they're saying if AB divided by QR, that's this side divided by this side, is going to equal AC divided by QS, that's this side divided by this side, and angle A equals angle Q, then the triangles are similar. All right. So again, you want to trace the triangles the same way. So if you go from A to B to C, all right, so that's past the red side and then past the black side, and then you do the same thing here. Past the red side, past the black side. So it's going to be QRS. All right, and that's what they said. So notice here that the sides are not congruent. They are proportional. Okay, but the angles in between those two sides are congruent. So A is congruent to Q. Okay, and the final method for similarity, Theorem 7.2, side, 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 or SSS theorem. If the corresponding sides of two triangles are proportional, then the triangles are similar. Okay, so basically, for this triangle here, they put each side in the numerator. Okay, so the numerators here are all side lengths from this triangle ABC. All right, and the denominators are all side lengths from this triangle QRS. Okay, remember when you put the two letters without the bar on top, that refers to the numerical length of the side. All right, so basically, they compare all the shortest sides, all the medium sides, and all the longest sides. Okay, it's hard to tell which is shortest and longest here, but that's basically what you do, and it has to be proportional. All right, and again, they always trace the triangles the same way. So if you start with ABC, and you go past the red, and then past the purple, you have to do the same thing here. So past the red, and then past the purple, that's going to be QRS. ABC is similar to QRS. Okay, problem 2. Are the triangles similar? If so, write a similarity statement for the triangles. All right, so let's see example A. As you can see, they did not give us any angles, okay? All they gave us are side lengths. So if they're similar, it's going to have to be side, side, side. All right, so I am going to set up the ratios and proportions just like before. All right, so we have 3 pairs of side lengths. I'm going to put SUT in the denominator. Well, let me write the 3 fractions first. All right, we're going to set up 3 fractions here. All right, and in the numerators, it's going to be triangle SUT, And then in the denominators, it's going to be triangle VXW. All right, so let's do the side lengths. The first fraction, I'm going to do the short sides. The second fraction, I'm going to do the medium sides. And the third fraction, I'm going to do the long sides. All right. So here we go. Short sides, we have 6 and 9. So for the short, I'm going to put a 6 over 9. All right. For the medium sides, we have 8 and 12. So for the medium fraction, 8 over 12. Okay. And then finally, for the long sides, we have 10 and 15. So I'm going to put 10 over 15. Now, there's two ways to see if these fractions are actually equal. Okay? You can reduce them, or in some cases, you might not be able to reduce them, and you can just do it on the calculator and get the decimal. Okay? I can tell by looking at these that I can reduce them. So I'm going to do it that way first. Okay, 6 and 9 are both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 8 and 12 are both divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. 10 and 15 are both divisible by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So as you can see, we have 2/3 for each fraction, okay? If you had done each fraction on the calculator, you would have gotten approximately 0.67 for each fraction, okay? As long as you can confirm that they are equal, then you know that the triangles are similar, all right? And now the only thing left to do, they wanted us to write the similarity statement. So let's do that. You want to trace both triangles the same way. So I am going to go past the short and then past the medium. So that's going to be STU. And then do the same thing on the other side. Go past the short and then go past the medium. So that's going to be XVW. Okay, and the triangles are similar by SSS. All right, we proved that all three sides are proportional to each other. So that's it. Okay, part B. Let's see if we can prove it. All right, we have a smaller triangle inside of a bigger triangle. All right, now these two triangles, both of them share angle K. All right, so of course we know that angle K is congruent to itself, angle K. All right, that's obvious. Now we want to make sure the sides are in proportion to each other. Remember, the angle has to be in between the two sides that are proportional. All right. So now in this case, since we only have two sides, we only have to set up two fractions. All right. Now, in the numerators, I'm going to make that the smaller triangle. So that's going to be LKP. And then in the denominators, I'm going to make that the bigger triangle. So that's going to be MKN. All right, now let's compare the sides. The first fraction is going to be the short side, and the second fraction is going to be the long side. All right. So for LKP, the shorter side is 8. And for LKP, the longer side is 12. right? And for the big triangle, MKN, the shorter side is going to be 8 plus 2, so that's a 10. And the longer side is going to be 12 plus 3, so that's a 15. Again, you can do decimals or just reduce the fractions, okay? I'm thinking I'm going to reduce them. 8 and 10 are both even numbers. 8 divided by 2, that's a 4. 10 divided by 2, that's a 5. Okay, both of these are divisible by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. So 4/5 equals 4/5. It checks out. Okay, and of course the angle in the middle of, in between those two sides is congruent to itself. Okay, so these are definitely similar. And we want to trace it the same way. So for the smaller triangle, I'm going to go past the short and then past the long side. So that's going to be LKM. And then do the same for the big triangle. Past the short. Let me erase this so it's not a mess here. Same for the big triangle, past the short side, MK, and then past the long side, KN. So that is MKN. Okay, the triangles are similar by SAS. Okay, please pause and try Got It problem 2A. See if you can prove these two triangles similar by SSS. All right, so for SSS, we need 3 fractions again. So I'm going to make 3 fractions here. All right. The first fraction is going to be the short side. The second fraction is the medium side. And the third fraction is the long side. All right. For the numerators, I'm going to use this triangle, ABC. For the denominators, I'm going to use this triangle, GEF. Or EFG, doesn't matter at this point. Okay, so for ABC, the short side is 6. And I guess you could say the medium side is also 6. And then the longest side is 9. Okay, and then for EFG, the short side is 8. The medium side, I guess, is also going to be 8. And then the longest side is 12. Okay, you can use the calculator if you like. I'm going to try to reduce these fractions. 6 and 8 are both divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Same thing with the mediums. Same fraction. Okay, for the long, 9 and 12, both divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. We have 3/4 for all 3. So it's definitely a yes. Okay. Let's trace the two triangles the same way. All right. So actually it doesn't matter as much for these. Since we have two sides congruent, there's a lot of ways to do this. So I'm going to go past the two sides that are congruent. So I'm going to go past the 6 and then past the 6 again. So it's going to be ACB. And then I'll just do the same thing here. Past the 8 and then past the 8 again. So that's going to be EGF. And those are similar by SSS. Okay, please pause and see if you can do example, got it, problem 2B. try to use SAS. Okay, in part B, we see that we have a small triangle inside a big triangle. Okay, both triangles use angle A. So we know that angle A is congruent to itself. All right. And now we just want to see if the sides are proportional. Okay, so we're just going to do two fractions now, short and long. All right, so that's one fraction, and that's one fraction. Okay, for the numerators, I'm going to use the smaller triangle, AWL. And for the denominators, I'm going to use the bigger triangle, AEC. All right. So for AWL, the smaller triangle, the short side is 6. And the longer side is 8. And for the bigger triangle, AEC, the short side is 6 plus 6. And the long side is going to be 8 plus 8. All right. Let's see if this works. You can do it on the calculator or reduce. I know that 6 over 12 is just a half, and I know 8 over 16 is just a half. So it definitely checks out. All right. So I'm going to trace both triangles the same way. When I make the statement for the small triangle, I'm going to say AWL. And then for the big triangle, I'm going to say AEC. And those two triangles are similar by SAS. All right, problem 4. Before rock climbing, Darius wants to know how high he will climb. He places a mirror on the ground and walks backwards until he can see the top of the cliff in the mirror. What is the height of the cliff? All right, so let's see here. All right, trying to center this. So they're looking for this side right here. That's X, the height of the cliff. All right. So first off, let's see if we can prove the triangles are similar. Okay, we have a right angle here, and we have a right angle here. So that's one angle. And then we have this angle here, congruent to this angle right here. So the triangles are definitely similar by AA. So really, you can make the statement, but all we have to do is to set up a ratio and proportion. Okay, so it's just going to be, since we only have 2 pairs of side lengths, it's just going to be 2 fractions. All right. So the numerator is going to be the small triangle, HTV. And the denominator is going to be the big triangle. That's going to be JSV. Okay. And the first fraction is going to be the bottom part. And the second fraction is going to be the height part. All right. So the bottom of the small one is 6. The bottom of the larger one is 34. So that's 6 over 34. The height of the small one is 5.5. The height of the big one is X. Okay, so in this case, I'm going to cross multiply. Top times bottom is 6x. Bottom times top is 34 times 5.5. Okay, solving for x, you want to divide both sides by 6. All right, the 6's cancel, and I'm going to do this fraction on the calculator. Okay, and I get 31.16 repeating. So it's just going to be 31.167. Okay, and it was in feet. So I'm going to write feet. All right, and that's what they said, about 31 feet high.